Hey, welcome back to the next lecture, lecture number 3. We just have the numbers on these things other than just in the title. Okay, again, fairly straightforward set of review exercises, so no, it's not going to be the case that it's always going to be the same pace. Really, the first couple of weeks, it's because we're kind of waiting to make sure everybody comes in because, well, sometimes there's last-minute additions and so on. I promise starting next week we'll get into hard stuff. I know you don't want that, but anyway, that will be end up what's happening. But in any case, again, the whole purpose of the first couple of weeks is just to really make sure that, yeah, you got to sort of jog your memory about some kind of important things. One thing that is missing is, sometimes there's a little less problem solving that maybe could have gone into the first couple of lectures, but don't worry, we will have plenty of time for that. All right, so here we go. Types, the usual type of thing. Yeah, I'm going to be doing all the stuff in the slides, but not by reading slides. I'll bring it back occasionally if I require, but I think it's probably a little more interesting to look at other things. As usual, there's a bunch of sections out of the textbook you can go off and take a look at. Okay, since I've got most people here, just a reminder. To prevent you from ending up being surprised at the end of the semester with attendance. Okay, the way how the attendance works in this lecture is you tap your card before you come in, and then you are responsible to make sure that your card tap has been recorded correctly in the system. Check PeopleSoft. If it doesn't work, or you forget your card, you can come down here at the end of the class and sign, and I'll mark you present. So there's no need for you to come down. I don't need everybody to come down and sign. Okay, just only if you forget your card. Okay. What will not work, however, is if you forget to tap your card and you forget to sign, and if you send me a message asking me to add the attendance, I'll forget to do it too. Okay. So in other words, don't send me an email afterwards saying, oh, I forgot all these things. No, you have to fix it during now. Okay, but otherwise, pretty straightforward. Just sign if you forget your card. Okay, so for today, what do we got? Okay, the very first slide, I guess the first slide, there's no reason for me to do anything because I think we've actually dealt with this already. Hey, come on, over here. Okay, we saw all of these types, so here, we'll make use of the slides that we've got, which happens to be just one of them. Okay, so here we go, primitive types. So a primitive type is a type of variable in Python that can hold a simple piece of information, one value of information, such as a number, piece of text, like some characters, also known as a string, a true-false condition, or a decimal number, and so on. There are other primitive types in Python, but really we're going to be looking at these 4 types, plus that one that I showed you the other day called none. This is the advantage or disadvantage of me not following the slides because sometimes I cover things multiple times across multiple courses. And that's completely fine, but let's put this away because now I think we can probably do some interesting things. I'm not terribly excited about this, but here we go. The next slide says integer and float arithmetic. Okay, so we better do some stuff. This is the best way is to do some examples. Unfortunately, the examples are kind of mostly made up, but we started on some of this last time, so we might have a number of credits that a course happens to be. And well, for example, this course I believe is 4 credits, and when we talked about fees, okay, and usually you get charged so many real per credit. I have no idea what it happens to be. So we'll say it's this much. And of course, if you print out the fees, it's not a big surprise. When you run it, you get some multiple of a number. All right, so fine, that's fine. But what I need to do is I'm just going to play around with a few operations here because I just have to remind you of some of the operators and what we might use them for. All right, first thing up that's very, very important. Okay, we started to do this the other day, and that is I started to introduce the type operator so we can see what's really going on. Okay, and here we go. If I print out the fees, okay, that's 7,200, that's fine. What is the type of that? Integer. As an integer. Now, the reason why you know that, of course, is because I just printed it. Okay, let's not print it and still ask the same question. What type is it now? Okay, you already know. All right, how do you know it's an integer besides the fact that we just saw it? The reason why it's an integer is because if we go back and we look at the individual types leading up to the calculations, credits is what type? It's an integer because there's no decimal point. If I do this, that now becomes a float. Okay, just leave it as an integer. All right, the very next line, it says you're going to take credits and multiply it by 1,800. Okay, so credits is type int. 1,800 is integer. And int multiplied by an int is still an int. Okay, and yeah, you're absolutely right. That's what it happens to be. If, for example, I start to make some other changes, like if I make this 4.5, well, now we might have a very different result. And the reason why we might have a very different result is because, well, credits is now a float. It was just said a second ago. And if you take a float and multiply it by an integer, you end up with a float because, well, now you've got the potential for decimal points. Yeah, I know there's no decimal points here because 4.5 times 1,800 is actually 8,100. We don't need the decimal points, but it's there because this is the way how Python works. If you take a float and an int and do any type of arithmetic between them in terms of a multiplication or an add, you immediately get yourself a float. Okay, so that's fairly straightforward. And the same thing, you know, even if I do this, even 4 point, that's actually enough to take it and turn it into a float. Okay, so float times an int will always turn out to be a float. All right, well, we need some other things as well. So let's see, there we go. Oh, and although it doesn't work this way, if I take the number of credits and add 4, this is not how they calculate the fees, unfortunately, it still works exactly the same way. So that one, and well, here, I'll just make it something so it's very clear. It's a float. All right, the same thing is true for, and that's definitely not how they calculate your fees. That would be okay because it automatically says you get a refund. But in any case, yeah, multiplication, subtraction, and addition, yeah, works exactly like this. All right, we need to now go and do something else, something completely different. We talked about calculating GPAs, and the way how GPAs work is when you have, when you take a bunch of courses, you take the number of credits and you multiply it by the number of units, and you get some kind of a score. So I'm going to call this score, and what this is a numerator, so I'll just make up some numbers. It'll probably be really bad numbers, and it's always based upon a number of credits. Okay, so here we go, credits. Like, for example, you take the number of credits, 4, if you get an A in the course, you get 4 times 4, that's 16, that becomes the score, and 16 divided by the size or the number of units that you've taken, it gives you the GPA. Anyway, let's just suppose that we have this. Your GPA would always be based on taking the score, dividing by the number of credits, and I'm going to print the GPA. And what do you think? Would that be a good GPA? Yeah, okay. A little unrealistic, isn't it? Okay, let's make this a little bit different just because I'm always making these things up. Let's suppose that it is 95, 95 credits, and somebody, okay, that's a legitimate GPA. Okay, and I won't ask whether or not you'd be envious of somebody with, no, that's not what it is. I guess it's an okay GPA, but of course it could always be better. It works like this. For you, it might be a good GPA, and for your parents, it won't be. Because they'll say, get better. Okay. But in any case, what I really want to do here is I want to take a look at the types. Now, something very kind of curious has happened because if you take a look at score, what type is it? It's an integer, okay. And credits? Now, that's clearly an integer. And look what I did. You see, when I add 2 integers together, I get an integer. When I multiply 2 integers, I got an integer. When I subtracted 2 integers, I got an integer. And when I divided 2 integers, I got a float. Okay, that's the rule about how Python works. Okay, and yes, if we print out GPA, type of GPA, okay, yeah, you get back a float. Okay, excellent. So yeah, that's the division. Regular, everyday, regular division, 2 ints divided by each other, yes, you get exactly a float. In 1101, you would have definitely seen this operator, oh, sorry, not that one. This operator right here called // and that has a very curious result. What this will do, well, it depends on who you end up taking the course from. Some of your instructors may look at that and they may call it integer division. because in the world of C, C++, Java, C#, JavaScript, and a whole bunch of other, okay, JavaScript isn't, but all of the older languages, if you ever took an integer and divided by an integer, you always got an integer. And what it would do is it throw away all the decimal stuff at the end. And that's kind of what this does. It will take the number 356 and divide it by 95, and it'll throw away all the decimal stuff at the end. So 3.747368 blah, 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 would suddenly turn into just being the number 3. All right. The question that I have is, okay, so the answer is going to be 3, but is it going to be a float or is it going to be an int? Okay, well, I mean, best way is to find out. Yeah, this is what happens with the / operator. It actually, but unfortunately, it isn't actually integer division. It's something a little bit different. Officially, this is called floor division. Okay, it's slightly different. Okay, and sometimes it can be a really big surprise. Let me remove anything to do with division for a second while we understand how floor works. All right, there's a package. You've seen it before. It's called math. All right, here we go. We're going to have x. We're going to pick up a number. Okay, there we go. There's a number. Well, I'll make a bigger number. There we go. 46.567. And what I'm going to say is I'm going to say y is equal to, I'm going to say math.floor, x. All right, so, and we'll print the value of y. And since we're here, we'll even print the type of y. All right. Floor division. Remember, we end up with an integer at the end. All right. Floor division says you do the division, then you calculate the floor. The floor is right here. I'm standing on it. And what this is, the floor is the biggest integer, which is just below where I am, because this is where I stand. So in other words, 46.576, the biggest integer, which is just below this, is 46. Okay, that's floor. Yeah, 46, exactly the same thing. Okay, because the biggest number, which is just below, is 46. Curiously enough, however, yeah, that turns out to be 47 because basically, because it's so many digits, Python just said, okay, well, they really mean 47. Okay, this can sometimes happen. That's one surprise. Yeah, somebody said 15 digits. I think I can't remember I did in this course or another course. But you have to watch out for that. Okay, let's get back to something normal. Okay, we'll get back to something normal. And what I want to do is I would like to talk about the floor of a negative number. Okay, because this can sometimes be a little shocking, because again, you say, okay, the floor. Well, all I do is I get rid of all the stuff after the decimal point. Okay, here you hide. Hello. Okay, go away. Clear the output. Okay, but when you run this, instead of getting a negative 46, you get negative 47, and that immediately becomes like, what? What's happening? Again, remember what it is. The floor operation says take the biggest number, which is just below the number that you asked to take the floor of, and of course, the biggest number, which is just below, is actually negative 47. Remember your number line is the one just to the left. There's another operation. We usually don't have to worry about it, but if you ever need it, guess what the opposite of floor is? Yeah, ceiling. It's probably spelled C-I-E-L. I don't use it very often, but I'm sure if we look it up, it's probably called this. I suppose we could try it. Okay, what's the worst that'll happen? Seal? Yeah, that's how they spell it here. Okay, so if you're looking for the next number that's just above, and this would be the smallest integer, which is just above. Okay, it's not something that we use very often. The floor is probably more useful, and the reason why I have to include it is because, oh, and of course it turns into an integer. The reason why I have to include it is because if you say x//y, this may end up giving you a very unexpected result. Like it might be less than what you're expecting. Hey, but that ended up being a decimal. Oh no, now we have to try some other things. Oh, isn't this miserable? Okay, so let's have one called z. Okay, so here we go. X divided by y, and I'm going to print out the value of z, and I'm going to print the type of z as well. Here we go, and sorry, got the wrong, fingers got in the wrong place. Whoops. Okay, so here we go. Now we're starting to get some, okay, that makes sense because I have one slash. Okay, that's good. This one, one slash, okay. Was it just a case that I messed something up? No. If you try to do a floor division on a float and an int, you get back a float. See, well, I suppose it's at least consistent, but just watch out for this type of thing. Okay, next one up. Let's see. Oh, sorry, we've got another operator. Then I have to cover a really important one. Okay. Okay, this is read as
3 squared by 5.
3 raised to the power of 5. Okay, so it's 3 times 3 times 3 times 3 times 3, which is not 15. Okay, 243. So 3 times 3 times 3 times. This works. This is completely fine. And yes, you can raise it to even weird powers. Okay, there's no library you need to bring in. That's quite handy. Please, you have to watch out for something because sometimes I do see students trying to do something like this. Like they want to calculate 2 to the power of 8, and that, of course, will produce. Yeah, that's what you would hope, but instead it gives you the number 10. So what is this? That's something we don't cover in the course, but if you want to, I can certainly explain it. Okay, it's a bitwise exclusive OR. Basically, it figures out the binary equivalent of 2 and 8, and it goes through, and if both bits are different, then it becomes a 1 in the output. Luckily, it's not part of the course, so we can kind of ignore it. But here's the problem. It's not an error. Okay, that's the thing. It won't cause an error. Sorry, it won't cause a syntax error, won't cause a runtime error, but it's probably going to give you the wrong output if you try to use it. Okay, so just watch out for that one. So that one can be quite surprising. And exactly what I said right here, this can become a real issue when you're dealing with negative values. Okay, is it important to have them for negative values? Well, no, just be cognizant of what's going to happen. All right, next one up. I only brought this up because I didn't want to try and draw this. If I had a marker, they get angry if I draw on the board. Or sorry, on the projector screen because you can't erase it. However, when you do the calculation here inside the box, so this is taking the number 4,235 and dividing by 7. So the way how you will have learned how to do this a really long time ago, you would have said, okay, well, I'm going to pick a 2. And of course, 2 times 17 is 42. You subtract a 2, you get an 8 as a remainder, you drop the 3. You do everything all the way down. And the thing that's up here is called a quotient, which, by the way, is exactly what you get when you call slash slash. Okay, that is essentially the quotient. As long as you're not dealing with negative numbers, it is completely fine. And what you get as the remainder is the thing that you end up getting if you were to use the percentage symbol. So let's toss this aside and let's do a small example. So if I wanted to take the number 4,235 and y was the number 17, all right, here we go. An x slash y, that was the quotient at the top. And if you're looking for the remainder, of course, then you use percent or modulo. Okay, very, very critical, by the way. This modulo operator is used in a lot of cases. We use it primarily just to check and see if people know if numbers are divisible evenly by something else. And one of the things I can tell you is that, or I suppose I can ask the question, is the number 4,235 evenly divisible by 17? And the answer is no, because when you do the division, there's a remainder. If it's exactly equal to 0, then it would be exactly evenly divisible. For example, if I simply take 2 values off and I get back the answer, I can tell you that 4,233 is evenly divisible by 17. You would tell this on a calculator. Let's see if I got a calculator here. There we go. By taking 4,233 and dividing by 17. All right, so we use this all the time. You do a remainder calculation, remainder 0, then you know it's evenly divisible. For sure, you've seen that in 1101. Now, is there something else? Okay, so why do we have these things? Like, why does this exist? Okay, first of all, to know if something is evenly divisible by another number, yes, it's actually really, really helpful. Let me see if I can come up with some really kind of cool things. Wrapping around in circular buffers or lists. Okay, that's really cool, but unfortunately most of you probably won't see it because it will be in the data structures course, like it's a third-year thing. Hashing functions, again, you won't see it because you're not taking a data structures course, but I'll remind you about how those work later because there's some really cool things. And it's also used in a whole pile of cryptographic algorithms. Okay, let me see if I can give you an idea about what I might use something like this for. Just so you have an idea about what you might use it for. Course name is equal to INFS1201 introduction. I can't even spell this. Introduction to programming. I know it could be even more than that, but that's fine. Here we go. That's good enough. All right. I want you to print this on a single line. Easy? Yeah, of course it is. Ooh, wow, it was pretty easy. All right. I want to print each letter in a single column. All right, now, I know that we haven't reminded you of loops, but I know that everybody has seen these in INFS1101. So I'm going to have a variable called POS. The very first letter in a string is always at position 0, and I'm going to say, well, POS is less than the length of the course name, and I'm going to print POS. And I'm going to say that POS goes up by 1 each time. Here's what happens. It will list all the numbers from 0 up until, well, whatever the length of the course is. But instead of printing POS, I'd like to say course name at position POS. All right, here we go. So what I'm doing is I'm literally going through, I've got an index pointer pointing at each location inside the string, and I'm pulling out one character, I'm printing it to the screen. Okay, that's pretty straightforward. And I know that you would have seen this in 1101. Now, I want to make this a little bit more interesting. I would like to print 5 letters at a time and go down to the next line every 5. Okay, so I want to print INFS1, new line, 201 space I, new line, NTROD, new line, and so on. I'm going to build up like a little rectangle. I can use modulo operators for doing stuff like this. I use this all the time. First one up, okay, this is a review from last class. If I say end is equal to nothing, what happens?
There's no space.
Yeah, there's no space. Sorry, this is end, not 7. Yeah, so there's no new line character. If I run it, it goes back the way it was. But instead of going out as one single string, it goes out as one character at a time. It'll actually be kind of slow compared to printing an entire string, but the result looks exactly the same. But watch this. This is actually sort of neat. I use this all the time for repeating patterns. If POS mod 5 is equal to 0, okay, here's what I'm going to do. Oh, if I say print and with nothing, what does it print? Really? If I say print nothing, what does it print?
Nothing.
Oh, good. It prints nothing. But after the nothing, it puts a new line character. So take a look at this. You see, it came up as kind of this cool little thing where it prints out every prints out 5 characters, and then it prints nothing, well, followed by a new line character. And now I can make some just really small changes. Like if I make it 7, yeah, I'm going to reshape my little diagram. I use this type of thing all the time when you're trying to repeat patterns over and over again. Go so far and then go back to the beginning and keep on repeating, maybe with different values. Maybe you want to do it once and next one you want to have uppercase characters, these types of things. But in any case, yeah, this can be kind of clever. It's used when you want to repeat patterns. So it does have some purpose. It just happens to be an INFS 1101. Trust me, the most common thing that we get is this number evenly divisible by another? Now, sometimes we get MCQ questions. Okay, tracing questions. I better show you how to deal with these ones because it turns out that not everybody knows how to do this. So here's some random value. All right, and y is going to be some other random value. And I'm going to have r is equal to x modulo y, and I'm going to print r, and I'm going to ask the question, what is that? Quick. Come on. Oh, you don't know? You want me to run it, right? Yeah, I'm not going to. We'll run it afterwards. Okay, I'll give you something a bit easier, because this one you need to know. If you take x and you divide by 10 and look for the remainder, this is a very, very common pattern. You have to know it. You would have seen it this week in the lab. Okay, if you haven't done the lab yet, you haven't seen it, but you will there. This will always give you something that's very, very important. Tells you the very last digit, because it's always going to be the remainder. So, what is the output when I run this program? Yeah, it's always 4. Okay, when you divide by 10, it's really, really easy. The remainder is always that little bit at the end. It also works really well if it's a power of 10. Like, for example, if I say modulo 100, it'll always give me the last 2 digits. So this will be 74, right? That is very, very helpful, okay? All right, so let's get back to the real one. Oh, sorry, not that. Oh, what's the remainder of this? Actually, it'll be, what, 5,646,374. Okay, yeah, that one I know. This one right here. Okay, come on. If I had a program, I could do it. Obviously, if I hit run, you're going to know the answer. Okay, let's find out how to do this if you don't have a program. And the reason why I better do this is because you might get into a situation in a quiz, like one of these MCQ questions, where you have a calculator, but you don't have access to a program interpreter, because usually we're asking, what's the output of this program? So you'd better learn how to do this using a very, very boring, everyday, simple calculator. Sorry, I don't know how to make this any bigger. And immediately say, yeah, but I can calculate the remainder because I got a percent symbol. No. The regular percent symbol on a normal calculator, that is percentage. If you are lucky and you have a programmer calculator, you might have something, like I've got one right here called mod, that is the percent operator. But unfortunately, we don't enable the programmer calculator, and D2L actually doesn't exist. But you do have access to a simple calculator. Okay, so the way how you do these types of calculations, okay, you take the big number, the one that you're trying to divide into, so 564,637,637,4. Okay, so 5,646,374. If you want to know the remainder, you take this and you divide it by the other number, 654. 654. Sorry?
I divided the number each time until the last number.
Well, that's one way of doing it. Yeah, I'll show you a quicker way how to do it. Okay, do this calculation right here. You actually have 2 pieces of information. You have the quotient. The quotient is the stuff before the decimal point. Okay, so in other words, if I said x//y, it would be 8,633. Okay, so that one's done. I'm not interested in that when I'm looking for the remainder. What you do is you subtract it. Now I can't even see it. And I can't even make it any bigger. 8,630, okay, 8,633. Just subtract it. You get a number that's less than 1. Okay, that's effectively the remainder. But the thing is that the remainder is in decimal format. If you want to put it back into a regular remainder format, you take that number, you multiply it by whatever you divide it by, so 654. All right, so there you go. So the remainder is 392. Okay, so if you ever get stuck and you're trying to calculate what something happens to be for a remainder, all you have is just this rotten little calculator, no problem. The only thing you have to watch out for, of course, is if it's a negative value. All right, so put this out of the way. There are some really odd things that happen. Oh, yeah.
Can you please just repeat this step?
Sorry?
Can you please just repeat this step?
Oh, sure. Okay, no problem. So I'm going to pick a scientific calculator, not because I need it, but it's just a little bit bigger. All right, so what I did, here, let's get rid of this one. Okay, I took the number on the top because you got a top divided by bottom. Okay, so 5,646 and 374, and I divided by 654. That gives me a number, and I basically want to get rid of the integer part. So I've only got the fractional part. So subtract, in this case, 8633. That will give me a number that's between 0 and 1. and you just multiply this by whatever you divide it by, so 654. That'll be the remainder. Okay, so if you ever get a question you're not sure how to do something, that's exactly what you do. Don't do this. Don't waste your time when you're dividing by 10, because it is a waste of time. It's just the last digit. Okay, that one's easy. This one's also easy. That just tells you whether or not a number is even or odd. This will be 0 because it's an even number. If I changed the number and made it this, it would be odd. It would be a value 1. Okay, and that's the typical things that we see. Now, where did sorry, let me find my slides. Okay. All right, so we've done all that. Okay, next one up. Okay, string indexing. Okay, pretty straightforward. Okay, I guess I can do it this way instead. All right, so here we go. Course name. I had it a while ago. INFS1201, Intro to Programming. Okay, it gets smaller and smaller as we go. Obviously, if I print course name, okay, you see the entire course name. We kind of did a little bit of this already. If I ask for the item at position number 1, I guess that's probably a better one to start with. What letter is that? N, because it's the second letter. And of course, well, 0 is the first one. Okay, all right. That's fine. Something you have to be, of course, careful of is a -1. Yeah, it's the very last character. Okay. Please don't carry that forward in any other programming language that you work on, because that's a Python thing only. So sometimes in my other courses, people are trying to do things like this. Yeah, it certainly works fine in Python. It's just if you continue on in programming, it's probably not true. It's probably not true in any other case. If I ask for position -2, yeah, it's the second to the last item. Okay, and if I ask for position number 500. Yeah, that's kind of an error, because guess what? There's not 500 characters in this string. So you end up with a string index out of range. Okay? And in a lot of other programming languages, negative numbers give you exactly the same thing. All right, so that's pretty straightforward. Okay, what comes next is something else. This will become important because we'll be back to deal with it a whole pile of times. All right, I hate to use the variable x, but usually I start off with x as just unknowns. Okay, so that's just means I don't know what it is yet, but we'll figure this out. Oh, I know. Print type course name. Okay, what type is a course name? String, str, excellent. And what type is the thing at position 0 inside the string?
String.
Let me clear the output. Okay, that's a string. Okay, you have to watch out. In some languages, that's a character, but in the world of Python, it's a string. It's a string with exactly one character, but it is a string. Okay, so that's important. All right, next one up. Okay, so x. X is equal to course name. What do we want them to do? Okay, let's go 3:8. Print x. All right. And I know this has been covered in the last few semesters in 1101. It's kind of a beginning, and this type of thing will come back many, many times as we go through this course. This has a property, an operation known as string slicing. Very, very helpful if you have a string and you're trying to do something where you're extracting little pieces of strings and putting them in somewhere else. All right, the way how this works, when you put two numbers with a colon between it, you're not getting back a single character, but instead you're getting back a whole bunch of characters, well, possibly. Okay, we'll talk about all the possibilities. And here's what you're saying by providing the two numbers. You're saying, please start at the first number and go all the way up to, but don't include the second number. So I am looking for characters from position 3, position 4, position 5, position 6, position 7, but not position 8. Okay? All right, so if I run this, you can see here, now unfortunately what I'll have to do is we'll have to count these things. Okay, this is position 0, 1, 2, 3. All right, so this is position 3 right here. This is number 4, number 5, number 6, number 7, but it doesn't include 8. But unfortunately, I can't prove to you it doesn't include 8 because I unfortunately got a space. So maybe it's there, maybe it isn't. I think what I will do is I will go up to number 10. Okay, here we go. So we know that this is position 3. 4, 5, 6, 7, 8, 9. But it doesn't include the N because that would be position 10. Okay, so pretty straightforward. Oh, and by the way, although you can hard code the values like this, and these are the ones that I always do, you can even do something like this. To POS, and we'll ask the user to input, we'll say from 3 until what position? Yeah, you can use variables in here. All right, so for example, if I ask for position 10, there you go, that's exactly it. Okay, let's run it again. Let's ask for 3 to position 3. Okay, we'll make it easy. Position 4. How many characters is that? It's exactly 1 character. Good, it's an S. I think we better do this as well. We better print out the length of X. And I hope everybody knows what that is. That tells you how long a character happens to be. All right, so from 3 to position 4, that's exactly 1. Okay, perfect. From 3 to position 3. Yeah, it's 0. So when you print X, you're actually not going to see anything. But you have to be careful because sometimes you might think that it's a space. Okay, so that's why I wanted to put the length here. All right, good. So let's go in that case from 3 until position 500. Basically, it goes from 3 until the end. So it stops at the string. It's not an error. Okay. If you'd guessed an error, yeah, it certainly seems reasonable. But no, it just keeps on going. So in that case, when you start mixing together negatives, you get some really bizarre behaviors that may or may not be as you expect. In this case, at least it kind of does match. So if you think about position -2, we're talking about the second to the last character. All right, and that's exactly what you got. We got up to, but not including the second to the last character. Okay, so at least that's consistent. Okay, so there you go. Yeah, we'll put this away. This is what you might use it for. We'll come up with a better example in a few minutes. All right, so here we go. So from the start to the end, yeah, obviously start and end could both be variables if you wanted to ask the user. Sure.
So what is it? 124 then?
That's how many characters there were. Remember what I printed right here was the length? So just so we could see like how many things were actually included. Yeah.
Sir, in the before example, you said, let's suppose we put course name and 1. It will come n as a string, right?
Count n as a string. Sorry. Let me undo this a little bit. Okay, so here I am.
So basically, what you did course name and the square bracket
Yeah.
1, square bracket close. That will be as a string, right?
Right here.
Yeah.
Yeah.
This will be type string, right?
It will be a string, yes.
So what if there is a space after 1201? Will that also be a string?
1, 2, 0, 1. So, well, this is a space right here, right?
Yeah. So will this also be a string?
Do you mean if I'm asking for this position right here?
Yeah.
Yeah. Every single character you pull out will be a string. Okay? Yeah.
Can we convert from strings to integer or not?
If it makes sense. If I remember, I think we did this previous class, but I don't mind trying it again. Okay, so the question is, can you convert from a string to an integer? And the answer is yes, but only if it makes sense. Okay, and we will do this. So here we go, int course name. Okay, how's that going to, oh, and we'll print the value. So I suppose the question is that actually going to work?
No.
And the answer is no, because unfortunately the course name is filled with stuff other than digits. Okay, if it only contained, say, this value right here and absolutely nothing else, then it's allowed. Okay, so yes, you can do the conversion, but you can't have anything else other than digits. Okay, let's get back over to here. Okay, value now, I should have used X, but in any case, course name. Okay. Okay, what do I see then? Start at 0, go to 4. Yeah, INFS. Oh, okay, that could be useful. Exactly the same thing. So if you leave out the first number, it means start from 0. Okay, and that's sort of a common kind of a common thing. The second thing here, if you go from 3 colon and you leave out the very last thing, it goes from here to the end. It's kind of like having a -1 at the end. So there you go, there's everything else. This can be really, really useful for sometimes if you want to get rid of the first few characters and you want to keep everything else. Okay? And there are many times where this pops up. We'll have to come up with a real example here in a few minutes. But in any case, if you leave the second one out, it goes from wherever the start is until the end. And what if you leave out the first and the last? Yeah, so everything from the beginning until the end. Well, hang on. That's just exactly the same thing. Yes, it is. However, it actually does something. It actually makes a copy of a brand new string. And sometimes that can be important. In terms of strings, it's not that important. When we see this again in lists, this is actually kind of critical. Okay, but it works exactly the same. All you're doing is you're making a brand new variable with exactly the same things. All right, there's also a third one, which is kind of strange. All right. Okay, we've kind of already seen this. What does this print? No, it prints everything. Well, as long as I don't slip and hit something. It prints everything. Starts from 0, goes right up until position 200, or everything is always or until the end of the string. All right, so from course name to this, there's a third parameter, and I know that you would have seen this in the 1101 just recently. The final option down here is, well, it's optional. In fact, the second's optional, but the third one's also optional. It's called the step. And what it's doing is it's saying, this is how many characters to move forward each time. So I'm going to go through each of the characters, but after I get the character, instead of going forward 1 step, I'm going to go forward 2 steps. So when you run something like this, you get if 10 space what this is it gave you the value I, then it skipped the N, it gave you an F, then it skipped the S and it gave you a 1, then it skipped the 2, gave a 0, then it gave a space, then it gave a small n, then it gave a small r, and so on all the way to the end. Really useful for strings? No. But it's here. Okay, even if it's not useful doesn't mean we don't ask questions about it. That's the one thing I've discovered about courses. It's not something I would use very often with a string. Okay, but it's here in case you ever needed it. I've never seen a use for it, other than it makes really good test questions. All right, if I stick here a 3, yeah, every third character. Okay, so first character, skip the next 2. Oh, since we're here, this one's a bit interesting. Start at position 1, which is the second character, and skip every other one. So it's all the other characters that we just didn't get the first time. Okay, all right, so from there to there. In that case, how about this one right here?
Goes back.
Go from 0 until the end of the string, but after you get the character, go backwards. Wait a minute. Yeah, that gives you absolutely nothing. But what you could do is you could reverse the 2 numbers and say go from 200 down to here. So if you get a big number and a small number with a negative, you can actually step backwards. Again, useful. I guess if you had to reverse a string, it's useful. It's one of those things I don't think I've ever used. However, even though I don't use it with strings, when we have lists, which also have slicing that works exactly the same way, it does have some use. Okay, so it's not just a complete waste of time. It does have use, just maybe not with strings. All right, now to my next slide. Okay, so next comes a pile of slicing examples. I've done a whole pile of slicing examples. All right, I've got 2 more things I have to do. Yes?
Why is the I not included?
Oh, yeah, that is kind of unpleasant, right? Because it goes all the way down, but it doesn't include. It doesn't include the 0. If you wanted to include that, I didn't notice that one. What I would do is I would probably run it this way. I know that this one includes, okay, because it will go off to the end. Because remember, the second number is normally a -1. Okay, Hey, good observation. All right, got a couple of extra things, and we'll come back and we'll actually do a real problem for something. And it was a problem, actually, that was on one of the tests. So, but not quite this simple. I mean, it was much more complicated, but I can at least solve some of it. So if you see the problem later as a practice, you'll say, hey, yeah, I remember how to do that. All right, here we go. We got two more operations. Here we go. I don't have student names here. Oh, okay. INFS1201. That is actually built up of two pieces. The first thing is called a department, and the department's called INFS. And then there's a course code, which is 1201. Okay, and actually, I could even pull up some code that I was working on just before I came here. I'm doing a whole pile of stuff. I'm pulling data of a spreadsheet, and the spreadsheet has INFS in one column and 1201 in the other. Well, all the different ones. And what do? Well, I'm pulling them together to make a single course. So here we go. This is what I'm doing. I actually call it the course code, and what I do is I take the department and I add to it the code. And then as I print out the course code, I get a problem because you can't add an integer and a string together. Oh, that's really miserable. Yeah, but what you can do is you can always take two strings and add them together, and you get something called string concatenation, which just simply means you're putting the two strings together. Sometimes you might want like extra characters between them. I would say like the most common one might be like a space. And yeah, so if you need a space between them, just go ahead and add them. So a string addition just means to concatenate the strings together. We will be doing this type of thing quite frequently. In fact, it's got a very, very common pattern, so I might as well cover this right now. I'm going to have a variable called result, and I'm just going to say absolutely nothing. I'm going to say result is equal to result plus h, then result is equal to result plus e, then result is equal to result plus L, then result is equal to result plus another L, and then result is equal to a result plus an O, and then I'm going to print the result. So what's the result when I print it? Hello, because what I'm doing is I'm starting with nothing. That's what that first line says. It's an empty string, and what I'm doing is I'm building a string one character at a time. This I'm doing in my WebTech 2 course right now. Well, we're about to do this. Very, very common programming pattern. You have a string, you start with nothing, and you keep building onto it to make it bigger and bigger and bigger. Okay? It's a common pattern. Normally we'd stick it into a loop, but you don't always need to have loops. All right, we saw, I believe, the following problem. Remember how to spell this. I'll even use the one that's here. Okay, does anybody know what an ellipse is? This is when it says read more ... The ... is the ellipses. All right, so how many dots go in? Three, okay. What if an ellipses had 100 dots? Okay, so here we go. 1, 2, 3, 4, 5, 6, 7. Yeah. Something that I just said in my other course this morning, you copy and paste something once, maybe it's okay. You copy and paste it twice, it's probably wrong. If you copy and paste it 3 times, it's definitely wrong. All right, so if you're doing something repetitively, it means that it's wrong. And you can take any string that you want and you can multiply it by a value, and what happens is it simply repeats everything over and over again. Okay, so there you go. You need 5 dots, that's how you get 5 dots. Okay. All right, so that's one thing. Next thing up. Literals, okay, string literals, we already talked about that. Okay, here we go. Here's another result. Okay. Okay, not a big deal. Okay, what do you think about this?
It's orange.
Oh, but it's part of the string. You see, the string goes across multiple lines. What do you mean, no? Yes, it is. Oh, you mean it doesn't work. You're absolutely right. It doesn't work. You're not allowed to take a string literal and break it across multiple lines. There are some things that you might be able to do, like you might be able to terminate this string and then put a plus and then come down here in the next line. and continue on. And I will even get rid of this in a second. Or sorry, we'll get rid of this one. We'll find out what's allowable, what's not. No, that's also not allowed. However, you might have bumped into this one. It's a line continuation. This type of thing is allowed. Okay, that is allowed. So you have a really long string that's going on too long, yeah, you can do it this way. However, I want to go back to the other way for a second. You see, it's not very convenient to be able to have to do this, but there's another quote. Oh, well, you know there's a single quote. Okay, fine. But there's another type of quote that you may or may not have seen already, and it's a triple quote. Okay, and what I mean by triple quote is it's a quote followed by quote followed by quote. And you have to end it with a triple quote. All right, what this is, regardless of what you may have run, because as soon as I type this up, anybody who's been through this course before will immediately say docstring. Actually, no, it's a multi-line string. Okay, it works like this. When you start this, it's simply a string which goes across multiple lines. And this can be really, really helpful, especially if you're dealing with like web development or something that goes across multiple lines. This can make your code much easier to understand. You don't have to use it. You can use it in any other way, but this is sometimes really helpful. Sometimes I use the triple quoted strings for dealing with other things. Okay, but anyway, since it's here, I will include it. All right, next up. Okay. We better have a few extra items. What are we going to do? Okay, let's see. Table of contents is equal to triple quote. If I can copy and paste what I've got, that will be better. Perfect. Okay, table of contents for a book about Python programming. There you go. Section number 1, introduction. Section number 2, Python variables, operators, functions. All right, so here we go. Let's write something about Google. Okay, what do we mean by Google? Well, what we're going to do is we're going to ask the user to input what to search for. Okay, and obviously, I'm talking about something that goes on much, much bigger than this. When I run this program, I'm going to type something like functions, and it's going to tell me whether or not it's in the book. Okay, right now it doesn't do anything. All right, so how can you find out whether or not a search item happens to be in a string, and it works for single strings, multi-strings, multi-line strings? No problem. Yeah. Sorry? Print? Well, print means that I have to look for it. Okay, I want the computer to search for it. Yeah, so there's a really nice operation. It's called in. And what it does is it says, check to see if the string contains any of the following stuff. If it is, I'm going to say that yes, it is there. Otherwise, I'm just going to say too bad. Or whatever else you want to say. So I'll just say wah, wah, wah. So just no. Okay, there we go. I suppose we could put out a sad face, but here we go. So what should we search for? Let's search for the word variables and ask, is the word variables inside the table of contents? Yeah, I see. Number 2, it says Python variables. So yeah, it's there. Now, the reason why you may have said no. Okay, so let's be realistic about this. Somebody who says no either just didn't know what I was searching for, or maybe they were expecting it to be on a single line. Okay, and that's a reasonable thing. So if you thought that, that's not how the in operator works. This is actually used for finding substrings. And what do we mean by a substring? It means that it contains something. And of course, that's what you want in Google. You don't want to have to type the entire page and say, I'm looking for a page that contains what I'm... No. You're searching for a couple of words. Okay. Unfortunately, there are sometimes some things that don't work out quite so well. For example, if you type variables like this, so is variables there? No, it isn't. Google is smart enough to say, did you mean this? Okay, but unfortunately we don't have it. That's not what in does. To make things even a little bit more tricky, what if I'm looking for function? Yes, but no, it isn't. Unfortunately, it's a capital F. So yes, the in operator requires that everything matches exact. There are things we could do to make it. We could take the entire table of contents and make it lowercase, and we can make the search term and make it lowercase. That would allow me to search for things. But it does work like this. For example, if I ask for D, is it there? Yeah, because introduction. Okay, but if I ask for simply the letter Z, yeah, that's not there. So it's looking for a substring inside. Okay, so that can be sometimes useful. Let me see, next page, what have we got? Oh, cool. Okay. Oh, we probably have a point where we can solve a small problem. How many slides have I got left? 15, so 4 more. Just let me skip forward for a second, just so I see what I've got. I want to make sure I don't run out. That's easy. That's pretty easy. That's all right. That's fine. If I don't get to the last slide, it's really not a big deal. All right, I'd rather do something else. So here we go. Okay, here's what I'm going to do. We'll write a little program. So sorry, I'll have to leave the comments up here. I'll simply say write a program that asks the user to enter. Remember a hashtag each time. Okay, we'll get to that in a second. Write a program that asks the user to enter a course code and decide and print the department and determine if the course is a third-year course. Practical example. This is what quite often people say, hey, we don't do any problems. Here's one, here's a real problem. We have enough material that we should be able to do this. So here's the idea. We come along, somebody's going to type in INFS1201, and it is going to tell me INFS. That's the department. And it's also going to say, no, it's not a third-year course. How do you know that INFS 1201 is not a third-year course? Pretty simple. The reason why it's not a third-year course, standard third-year course. I know people might be taking a third year, especially the banking fintech students, because things are out of sequence. But you can tell something's a third-year course by that first digit right there. Okay, that's the way how you tell. So if you see a number like INFS 4, that's a course that's normally taken by somebody in the INFS department in their 4th year. Okay, that's what the numbers mean. It doesn't mean that you have to, that's what it means. All right, so we need to be able to extract this information. Okay, first thing, this assumes that the user types things correctly. All right, how do I get the department? Okay, how do I get the department? Where's the department? No, somebody's going to type INFS 1201. What department is this? INFS, okay. And if they type DAX 1201, it's going to be DACS. Where is the department? It's always, from the string. How do I get the department? Yeah, the first 4 characters. Okay, good. So I go to the course code. Okay, I can't ask for this because that would only give me one thing. But remember what we just did. You want from 0 to 5. Okay, let's print it and see what we've got. Print department. All right, so let's find out. So here we go. We'll pick something different. Comp 1401. Bang. So why'd you guys pick 5? Because you're thinking you want to go with the 4. No. Remember, strings start from 0. Okay, so therefore the last position I need is position number 3. So from 0 to 3. So instead of putting a 5, you'd end up wanting to stick a 4. All right, so here we go. Run, and we'll say comp 1, 2, 3, 4. Bang, here we go. So comp. All right, perfect. Oh, is anybody feeling lazy? I am. Okay, programmers are incredibly lazy, and you see, that saved me 1 character.
Yeah.
Excellent. So we've made the program smaller. Sorry. Hey, where's it? Here, type. Okay, INFS 2222. Bang. So here we go. We've got it. Yeah, we just double check everything. That's the department. We can obviously print out something like the department is so on. Okay, something a little bit more precise. The next one, it's got a little trick to it. Okay, where's the year? That's in the course code. Okay, so what do I put here? I can't put 4.5, it doesn't work. Okay, you guys have to decide on this. Okay, let's count it up. So this is position 0. All right, that's position 1, 2, 3, 4. All right, so let's pull out this, and we're going to check it. Print year. All right, here we go. So code is, sorry, I don't know any of the banking fintech codes. So ACCT, we'll pretend it's accounting. I don't know if it really is. 2, 3, 4, 5. All right, department, ACCT. All right, and what year? 2. Seems pretty reasonable. Excellent. All right, now the exercise was determine if the course is a third-year course. So here's what I'm going to do. I'm just going to stick an if statement, and I'm going to say if the year is exactly equal to 3, I'm going to say, print, I'm going to say this is a third-year course, and otherwise I'm just going to say it is not a third-year course, whatever. All right, so here we go. INFS 1201. Okay. Department, INFS, we already know it works. Year 1. Should it say yes or no? Yeah, it says no. Of course it isn't. So it is not a third-year course. All right, very good. DSAI 3333.
Yes.
Yeah, okay, good. It says it's not. Ooh, okay, get to this in a second. I'll see what the question is first.
Can you please remind me, 9/11, why did you put 2 dots after 3?
Sorry, you mean the 2 dots right here? That's the syntax for an if statement in Python. Okay, that's a requirement. If you leave it out, Python is unhappy because it thinks that there's more stuff coming. Okay, so this means it's the end of the condition. All right, whoops, it didn't work.
Because it's a string?
Yeah, that's actually exactly it. So here's what I'm going to do. Print year, type year. All right, so here we go. INFS 3211. All right, you see, although it printed 3, it's actually a string. And guess what? The string containing 3 is not the same as the integer containing 3. So unfortunately, it's kind of a surprise. And that's the reason why I included this one. You'd have to typecast that to turn it into an integer. And now you should be able to get something to actually work. Okay, and now it will actually, just be careful of this. When you extract values out of a string, the results are strings. And yes, you can certainly type them, you can cast them back into integers as was asked earlier. So if I want to say the full thing here, then yeah, you just extract the full course code. It would be positions maybe 4 to the end, depending on whatever they typed. The thing that's kind of missing is it would be really, really great if, okay, I could validate that to make sure that if somebody types some random junk like, okay, what's the department? LDFK. Okay, is it a third-year course? Okay, so what am I going to see?
Yeah. This is not associated code.
No, you're going to get an error. Okay, why? It actually figured out the department because it was able to pull out the first 3 characters. That's not the problem. The issue is because we used an int here, it took the 4th character, or sorry, the character position 4, the 5th character, and it tried to convert J into an integer, but of course that failed miserably.
Yeah.
And that's exactly what the message says, invalid literal with base 10 for J. Okay. Just unfortunately, this is real life because people never do what they're supposed to do. If people would just do what they're supposed to do, it makes programming a lot easier. Okay, so what do you have to do? Well, you'd have to actually pull out the first thing. You'd have to ask, is it a digit? If it's a digit, then go forward with it. If it isn't a digit, you say, oh, hey, this is no good.
Yeah.
You could even check the first 4 characters and make sure they're all uppercase, and then stop the program if it isn't. Okay, well, that has to do with the problem you're trying to solve. All right, let's put this away. Okay, get back to this. Okay, the language is called Python. Oh, sorry. Oops, okay, I made a mistake. Without touching line number 1, can I fix this to be Python? Okay. When you say print language at position 0, what do I see? R, okay. Oh, a line. No, you don't. You get nothing. Okay, let's try it again. Excellent, excellent, excellent. All right, here's what I'm going to do. So if that's the individual character, can't I just do this? And although you can do it in a lot of languages, you can't actually do it here. One of the rules about Python in strings is you can't actually modify an individual character. It falls into a category, something called immutable, which unfortunately everybody assumes means that it's read-only, and it's sort of slightly different meanings. I think I've got slides about this later. But in any case, sorry, you can't although you can read a character out, you can't actually change anything. Oh, so it just means that you can't do it. Actually, there's tricks that you can do. Language. All right, well, string slicing, we just covered it. Yeah, what does this do? Just describe it. I don't want the output. What does it do? It starts from the character 1, goes to the end. So what am I doing? I'm throwing out the first character.
Yeah.
Okay, it's a very common thing, so it's just Python. If you want to put a P in front of it, it's no problem. You just put a P and then you concatenate. And then you take the result and you put it back into the original variable. So you're not actually modifying the string, but what you're doing is you're building a brand new string and putting it back into the same variable, overwriting what used to be there. So it's possible to do these types of things. It's just it's a little bit different. What you have to do is you have to rip the string apart and recombine it other ways. I do this all the time. For example, when I'm trying to take people's names out of PeopleSoft, like students, sometimes it shows up as last name, comma, first name. I pull it apart, I find out where the comma is, and then I flip the two things around and I put a space between them. Okay, so it's things like this. You can still do this in Python, it's just sometimes a little bit less convenient. Okay, we better do this. So let's spell it correctly. I should have brought over the program I was working on earlier because I've got a whole pile of these things. Like, I don't know, I've been working at this for the last couple of hours or something. All right, that's not a big surprise. So, again, usually in INFS1201. Okay, sorry, it's also a bit long today. I said normally I'd be done by 10 after. Sometimes it doesn't happen, but we're almost there. Okay, just a couple of slides. It won't take very long. A /n means a new line character. Okay, so what happens is the P will be displayed, the Y will be displayed,
And so on will be on
and
the
then the rest of it will continue on the next line. Okay, I've got to write up something that's very, very important, however, is the length of language. How many characters are in the word, in the variable called language? 8. Okay, I'm hearing 8. Somebody else said 6. So therefore the average is 7. Okay, good. It is 7. Okay. What we need to do is we need to count this. Okay, so here we go. Let's count it together. Okay. 1, 2, 3. Notice what I just did? 3. Yeah, the /n is a single character. Okay, so that's 3, 4, 5, 6, 7. That's why. Okay, so just watch out for that because it can be a surprise. Yeah.
Why is the backslash and the end together?
Why is it?
Consider the next line, right?
Yes, it is. Yeah. So what happens, the way how this is implemented inside the computer is new line characters being around for a really, really long time. It comes back from the days of typewriters. That is actually stored as a single character inside the string, and when you print it, it moves the cursor down to the beginning of the next line. So it's a way how we can sort of embed new line characters in the middle of strings if we have to.
It's part of the string.
But it is part of the string, yeah. Yeah, it is part of the string. Yeah. No, that is a new line character. That causes the output to go to the next line.
It's counted though, right?
It counts, but it only counts as 1.
Yeah, okay.
Okay, it only counts as 1. There's a couple of, these things are called escape sequences, and sometimes you actually need to have a backslash as part of your output, and yeah, that's if you wanted a backslash as part of your output, py backslash thon, then you use 2 backslashes. This one is also quite helpful. We're a backslash quotation mark. If you need like a quote to be part of it, you have to do what's called escaping. There's a handful of other ones that are used, like you may have seen something called a tab key. I never asked for this because it really doesn't work very well. All right, so here we go. All right, the final things. All right, there's a bunch of stuff about relational and Boolean operators. I don't think I really need to cover these. There's nothing weird about these. However, I will talk about lexicographical ordering just for like half a second or so. Anything else? This will be the final one, okay, and I promise it's not too much longer. Okay. And lexicographical ordering basically means the dictionary ordering. Okay, so if you were to look up these values in a dictionary, which would come first? All right, so pretty simple. Which comes first, apple or banana?
Apple.
Apple, because A. Okay, it's basically dictionary order. Cat versus car. Okay, and you can see something weird down here where I'm checking to see if a cat is less than a car. Okay, and I'm not talking about in size. I'm talking about where would the order appear. Well, car would come first because, well, R comes before T. So if you end up with the first few letters that match, then it starts to look at the next one. Dog versus doghouse, well, dog comes first.
Yeah.
So the root part of it is a pretty straightforward. ABC versus ABCD, again, the ABC would come first. The only thing that becomes a little bit weird is when you start to deal with uppercase letters. All the uppercase letters in the computer come before the lowercase letters. Always, always, always. It has to do with how the values are, how the ASCII characters have been sorted. Characters are always sorted from bigger to smaller, so A's come before Z's. But all of the uppercase letters come first, and then all the lowercase letters come. Why do they do that? Kind of historical significance. Okay, they could have done it the other way, they just chose not to. And again, at the time, a lot of the programming languages used uppercase letters only. Okay, so that kind of probably made a bit of sense to do this. We'll see this later when we try to sort things. Okay, the final thing I've got in here is just the Boolean operators about ands, ors, and nots. And if I had an extra 5 minutes, then I would do a little bit more. But there's nothing really kind of new in here. So I'll take the opportunity to not bore you with this for 5 minutes. Yeah.
I wanted to ask about the strings.
Yeah.
So, you said that it depends on the ASCII, right?
Yes, it does.
I know that ASCII has all the lowercase letters after each other, and then
Yep.
so you could have a capital C that's above an A that's lowercase, and it will consider that as the larger value.
Okay, since he asked, this is his problem, or sorry, it's his fault because we're late. Okay, you can wait outside. People beat you up on the. No, it's fine. This happens. All right, so I like these. This is actually how things are stored inside the computer. So if you want to store the letter H, capital H, it doesn't actually store the letter H. What it does, it stores inside memory the value 72. That's the ASCII value. And you'll notice here that, yes, all of the uppercase letters have smaller values than all of the lowercase values. It's the way they've organized it. But really the curious thing is if you compare, say, an uppercase A versus a lowercase a, they're exactly 64 numbers apart. And 64 is really important because it's a power of 2. There's a 32. 32, sorry, wrong number. Okay, so yeah, you're absolutely right. It will consider anything with uppercase letters as being before. Don't worry, I'm never going to ask that question on the test. The first one, however, do they show up in order from A to Z? The answer is yes. That's pretty easy. Okay, but I'm not gonna start tricking you and say, hey, where does a curly brace appear? Because this means you have to memorize these things. There's no point for that, but things are stored from smallest to greatest. Here's what I do is I've memorized 2 numbers. 3 numbers, sorry. There's 3 ASCII values I've memorized. I've memorized for capital A, which is 65. I've memorized for lowercase a, which is 97. And I've memorized the value is 0. The symbol 0 is 32. Okay, because these are obviously the things that we need all the time. Everything else, yeah, I forget about. Oh, the new line character, by the way, it's right here. Its value is 10. It's called a line feed. But it actually kind of goes along with the carriage return. If I had more time, it'd be really cool. All right, you guys have got to go because you'll have more classes. I spent too much time, and apparently I've got a meeting coming too. So I better stop. See you next week.